Hello students, we have done a lot about the nature of roots. Now let's discuss some questions regarding nature of roots. The first question, prove that the equation x minus a into x minus b plus x minus b into x minus c plus x minus c into x minus a equal to 0 have real roots. We have to prove that this equation have real roots. So first we will find the discriminant of the quadratic equation, and before finding the discriminant we will convert it into the standard quadratic equation. This x square minus a plus b times x plus ab, x square minus b plus c times x plus bc plus x square minus c plus and x plus ca is equal to 0. After simplifying, it is 3x square minus x times 2a plus 2b plus 2c plus ab plus bc plus ca is equal to 0. 3x square minus 2x times a plus b plus c plus ab plus bc plus ca. Now this is the quadratic equation in standard form. So we will find the discriminant b square minus 4ac. So what is the discriminant? 4 times a plus b plus c whole square minus 4 into 3 into AB plus BC plus CA. This is the discriminant of the quadratic. Now, A plus B plus C whole square minus 3 times AB plus BC plus C. After simplifying this expression, it is a square plus b square plus c square minus ab minus bc minus c. And we know about the sign of this expression. So what is discriminant? Discriminant is a square plus b square plus c square minus ab minus bc minus c. And this d is greater than and equal to 0 for all a, comma b, comma c belongs to R. So this equation has real roots because the discriminant is a square plus b square plus c square minus ab minus bc minus ca. We have done earlier. What is the sign of this expression? The sign of this expression is always greater than and equal to 0. So in this way, we can solve this question. Now come to next question. Write down the question. If the roots of x square plus 2rx plus pq equal to 0, if the roots of x square plus 2rx plus pq equal to 0, are real and unequal, then those of x square minus 2 times p plus q into x plus p square plus q square plus 2r square is equal to 0 are imaginary and vice versa. So the question is, if the roots of x square plus 2rx plus pq equal to 0 are real and unequal, then those of x square minus 2 times p plus q into x plus p square plus q square plus 2r square equal to 0 are imaginary and vice versa. So the meaning of question is, if this equation has real roots, so it is possible when this has imaginary, or vice versa. If it has imaginary root, then it is possible when this equation has real root. So let the first equation have real roots. So d1, that is b square minus 4ac. It should greater than 0. It should greater than 0 because in the question it is given that real and unequal. In the question it is given that roots are real and unequal. So what is b? 4r square minus 4pq. This should greater than 0. 4 common. R square minus pq. This should greater than 0. So r square minus pq is greater than 0. Means this equation have real root if r square minus pq is greater than 0. Now come to this equation. In the question it is given that it has a real root if and only if it has imaginary root. Means the discriminant of this quadratic should less than 0. So we'll find d2. What is d2? d2 is 2 times p plus q whole square minus 4 times p square plus q square plus 2r square. 2 times p plus q whole square minus 4 times p square plus q square plus 2r square. 4 common. P square plus q square plus 2pq minus p square minus q square minus 2r square. So after simplifying it, it is 4 times 2pq minus 2r square. 8 times pq minus r square. So what is the sign of this expression pq minus r square? That this is the equation 1. So from equation 1, excuse me, 8 times pq minus r square should less than 0 because r square minus pq is greater than 0. So we have seen if this equation has real root, then it will have imaginary. Because the discriminant of second quadratic is pq minus r square. Whenever the discriminant of first quadratic is r square minus pq. Or we can say that d2 is equal to minus d1. Or we can say that d2 is equal to minus d1. So whenever d1 is greater than 0, d2 will be less than 0. If d1 is less than 0, then d2 is greater than 0. So So in this way, we can prove it. Now, next question. If the roots of the equation, x square plus px plus q is equal to 0, if the roots of the equation x square plus px plus q is equal to 0, differ from the roots of the equation x square plus qx plus x square plus qx plus p is equal to 0 by the same quantity. Then show that p plus q plus 4 is equal to 0 unless p is equal to q. Then show that p plus q plus 4 equal to 0 unless p is equal to q. Now I repeat the question. If the roots of the equation x square plus px plus q equal to 0 differ from the roots of the equation x square plus qx plus p equal to 0 by the same quantity, show that p plus q plus 4 is equal to 0 unless p is equal to q. We have to show that p plus q plus 4 is equal to 0 unless p is equal to q. So if we notice, then we have to know that यहाँ पर हमें क्या करना है, एक P और Q में रिलेशन इस्टेब्लिश करना है. We have to form the relation between P and Q from these two equations. अब दोनों में अगर हमें दोनों इक्वेशन से अगर हमें P और Q में एक रिलेशन इस्टेब्लिश करना है, तो यहां पर कुछ ना कुछ कॉमन टर्म होनी चाहिए, एक कॉमन बात होनी चाहिए ताकि हम दोनों क्वाड्रेटिक इक्वेशन में एक रिलेशन बिल्ड कर सकें. For this purpose, we will assume that first equation has the root alpha and beta. In order to form the relation between P and Q, there should be some common thing between these two equations. And the common thing is the difference of roots. It is given in the question that difference of root of both the equations are same. So let the first equation has two roots alpha and beta, and second equation has two roots gamma and delta. So what is alpha plus beta? Alpha plus beta is minus b. What is alpha plus beta? Alpha plus beta is minus b. And what is alpha beta? It is q. Alpha plus beta is minus p and alpha beta is q. Now what is gamma plus delta? Gamma plus delta is minus q and gamma delta is p. Gamma plus delta is minus q and gamma delta is p. So what is common in these two equations? The common thing is mod of alpha minus beta is equal to mod of gamma minus delta. दोनों इक्वेशन में जो कॉमन बात है वो ये है कि difference of root in both the equations are same, because it is given in the question if the root of the equation x square plus px plus q equal to 0 differ from the root of the equation by the same quantity. given from the root of the equation by the same quantity. Then, so how we solve it? Now squaring both the sides. Alpha minus beta whole square is equal to gamma minus delta whole square. We have information related to alpha and beta are alpha plus beta and alpha into beta. And for gamma and delta, gamma plus delta and gamma into delta. So we will convert this alpha minus beta into the term of alpha plus beta and alpha beta. It is alpha plus beta whole square minus 4 alpha beta, and it is gamma plus delta whole square minus 4 gamma delta. So what is alpha plus beta? It is p square minus 4q, and it is q square minus 4p. So we can write p square minus q square plus 4p minus 4q is equal to 0. It is p minus q into p plus q plus 4 common, p minus q is equal to 0. So we can take p minus q common, and it is p plus q plus 4 is equal to 0. Since p is not equal to q, so p plus q plus 4 is equal to 0. Hence proved. Because we have to prove that p plus q plus 4 equal to 0 unless p is equal to q. That means p plus q plus 4 equal to 0 when p is not equal to q. And this way we can solve this question. Write down the next question. If the roots of the equation ax square plus bx plus c equal to 0 be alpha and beta. If the roots of the equation ax square plus bx plus c equal to 0 be alpha and beta, if the roots of the equation ax square plus bx plus c equal to 0 be alpha and beta, and those of the equation ax square plus bx, capital Ax square plus capital Bx plus c equal to 0 be alpha plus k, comma beta plus k. Be alpha plus k, comma beta plus k. Now prove that b square minus 4ac over capital B square minus 4 times capital A into capital C is small a over capital A whole square. Is small a over capital A whole square. Again, this question is similar to previous one. In this question, we have to find the relation between the coefficient of quadratic of first and coefficient of quadratic of second equation. See, in order to create this relation, both the quadratic equation should have one common thing, so that we can create a relation between small a and capital A, small b and capital B, small c and capital C. Now, what is the common thing in these two equations? What is the common thing in these two equations? If we notice the root, the first equation has roots alpha and beta, and the second equation have alpha plus k, comma beta plus k. If we find the difference of both the roots, if we find the difference, in this case, the difference of root is alpha minus beta. Difference of root is alpha minus beta. For a while, we will assume alpha plus k is equal to gamma and beta plus k equal to delta. And what is the difference of root in this case? The difference of root is gamma minus delta. So it is alpha plus k minus beta minus k. So what is the common thing in these two equations? The common thing is their difference of roots are same. इनके जो रूट्स का डिफरेंस है वो दोनों में क्या है? सेम है. So alpha minus beta is equal to gamma minus delta. Alpha minus beta is equal to gamma minus delta. Squaring both the sides, alpha minus beta whole square is equal to gamma minus delta whole square. Convert it into alpha plus beta. So what is alpha plus beta? From this equation, alpha plus beta is minus b by a and alpha beta is c by a. And what is gamma plus delta? Gamma plus delta is minus b by and gamma delta is c by a. So put it here. It is b square by a square minus 4c by a, capital B square over capital A square minus by capital A. This b square minus 4ac over a square is equal to b square minus 4ac upon b square. So b square minus 4ac for b square minus 4ac a square over capital A square. So in this way, we can prove this expression. This question has been asked in IIT, I think 1999 or 1998. So this is a very, very important question. Now come to some other properties related to discriminant. Suppose we have two quadratic equations. Suppose we have two quadratic equation a1x square plus b1x plus c1 equal to 0, and the second quadratic equation a1x square plus b1x minus c1 is equal to 0. Generally, we know that the quadratic equation has at most two real roots. So from these two quadratic equations, there are at most 4 real roots. Now we have to derive the condition from these two quadratic equations, at least two roots are real. Now we have to derive the condition from these four roots, from the two quadratic equations, at least two roots are real. Or in these two quadratic equations, at least one equation has real root. So how we derive it? Suppose the discriminant of this quadratic is b1 square minus 4a1 c1. And what is the discriminant of this quadratic? b2 square plus, b1 square plus 4a1 c1. Now, from this expression, there is no information regarding the sign of b1 square minus 4a1 c1. And similarly from the expression second, d2. So, if we notice it, d1 is b1 square minus 4a1 c1 and d2 is b1 square plus 4a1 c1. So what we do? We add them, d1 plus d2. What is d1 plus d2? It is 2b1 square. d1 plus d2 is 2b1 square. So from this expression, we can say that d1 plus d2 is greater than and equal to 0. From this expression, we can say that d1 plus d2 is greater than and equal to 0. So, what is the conclusion from this expression? The conclusion is, if the sum of d1 plus d2 is greater than and equal to 0, it is possible when at least one of the d1 and d2 is greater than 0. So this d1 plus d2 is greater than and equal to 0. It means at least it is possible when at least one of the d1 and d2 is greater than and equal to 0. If d1 is greater than and equal to 0, means equation first have real roots. And if both are greater than 0, it means equation have 4 real roots. So from this question, we have to know that what is the conclusion? In two quadratic equation, at least one have real roots. In two quadratic equation, at least one have real root if their sum of discriminant greater than and equal to 0. That means d1 plus d2 is greater than and equal to 0. Or in two quadratic equation, at least two roots are real if d1 plus d2 greater than and equal to 0. Or in other words, we can say that in two quadratic equation, at least two roots are real if sum of discriminant is greater than and equal to 0. Because in two quadratic equation, maximum roots are 4, and in that 4 roots, 2 roots will be real if their sum of discriminant is greater than and equal to 0. Similarly, in two quadratic equation, at least one